So for number one, it's important to know that the molar concentration of a solution fits into the broad category of different types of concentration units, in the category where you have the amount of solute over the amount of the solution. Okay? In particular, molar concentration that we symbolize as a capital M with a line under it. The way we measure the solute is in moles, and the way we measure the solution amount is in liters. Okay? What we're going to do to start this calculation is we're going to pick the amount in the problem of the solute, no matter what the units of measurement are, and put that over 1. Pick the amount of solution, no matter what those units of measurement are, and put it on the bottom, and then convert our way to get to these two units of measurement.
You make new references?
I've had some extras down there that may not have been used before. Okay. So the amount of solute is 2.75 grams of this chromium 2 bromide. And the amount of solution is 375.0 milliliters of that chromium 2 bromide solution. Of course, we don't know yet.
Hold on. How do you know what a solute is?
It's a thing that gets dissolved. By definition, solute is a part of the solution that gets dissolved.
So how do you know that it's solid in the
Because it says this is dissolved in.
Oh, okay.
Okay?
Alright.
So, we do need to know what the formula is, and we learned to write formulas in units 3 and 4.
Can I get that?
Since I have a Roman numeral of the name, you should already know that's an ionic compound. Okay? Roman numeral 3 means chromium has a 3+ charge. And we're putting it together with bromide. When we have an IDE ending, that means we have a monoatomic anion, a single atom anion with a negative charge. So you go to the periodic table with oxidation numbers and find the charge number for bromine, the negative charge number for bromine to get a bromide, and that's a -1. So to make this formula work out to have a 0 charge, I've got a particle with a 3+ charge and a particle with a 1 negative charge. I'm going to put these together in a way that gives me a 0 charge when I'm done. So I need coefficients here to find the number of each of these kinds of particles. I'm going to need 1 of these and 3 of these. So when I put it together, up here, I need 3 bromines. And so to make the formula then, I have 1 chromium, and the way that I show 3 bromines bonded together with that is to put a subscript 3. So that's the formula for chromium 3 bromide. Correct. If it were a 4, it would be a 4+ charge. If it were a 5, 5+ charge, and so forth. So this is Cr, Br3. And down here, we're going to name the solution for the solute species. So we're going to call it a chromium bromide solution. Okay? Now, to get from grams to moles, that's what we want to have, then this is something we've been doing since Unit 5. We've got to calculate, actually, we did a little bit in Unit 1. We've got to calculate the molar mass for chromium bromide. So we have chromium.
That'll go on the bottom.
The mass will, because I got mass here, I want the mass part of this on the bottom.
And then 1 mole will go on top.
Exactly. Mass will be on the bottom, mole on the top. Well, let's calculate the molar mass first. Here's chromium, 51.9961. That's its atomic mass. And here's bromine, 79.904. And since I have 1 chromium, I'll multiply this by 1. Since I've got 3 bromines, I'll multiply that by 3. And I've got an empty slot here on the right, meaning that means I'm going to have a digit on the end that I have to round off. So I'll underline that last digit to show that it's being rounded off, that it's an insignificant digit.
Why is it being rounded up?
Because I've got an empty slot right here.
Oh.
That's the rule we used for addition and subtraction. So now we've got that, what you were talking about, 291.708 grams of chromium bromide equals 1 mole of chromium bromide. And so the grams side of this equality statement goes in the bottom here so that I can cancel those grams. The other side of the equality statement goes on the top.
I got Maddie.
Am I wasting my time here?
No.
I see a lot of people that just don't seem to be paying attention. I want to make sure that I'm not wasting my time.
I told you what to put.
I know, I appreciate that, but there just seems to be a lot of attention to the card, which is fine, okay? But I need your primary attention up here. I'll try to make sure that everybody signs the card, okay?
Do you have a pen to pass around with the card in case people don't have a pen?
Borrow one of mine.
We'll put it on the card so people don't have a pen.
Just make sure I get that pen back, please, okay?
I know about that.
You know Michael.
All right. So I've canceled grams. I now have my solute. Really important. My solute's now in moles. That's what I want. But my solvent is currently in milliliters. I've got to get milliliters into liters. And I need an equality statement to get there. So 1,000 milliliters equals 1 liter. There's the equality statement that I need for this conversion.
So I was right, 375,000. No.
I'm going to put 1,000 milliliters on the top and 1 liter on the bottom. That's going to allow me to cancel the milliliters and will leave me with liters of the chromium bromide solution. Now I'm ready to do the math.
The multiplication?
The multiplication and division. You multiply this number times this number.
375,000.
And the way I've taught you to do it is to take that answer. So you hit equals or enter, then divide by this, hit equals or enter again, divide by this, hit equals or enter again.
And you're done.
And, well, you got to round off, but we get 0.025139.
It's going to be 0.03.
The units we have left are moles of chromium 3 bromide over liters of chromium 3 bromide solution.
Which is the same as M with a line under it.
It's the same thing as M as a liner. So
It's going to be 0.03.
no, I got to have 3 digits. Leading zeros are not significant. This is the first significant digit. Second, third,
So
underline there.
the 0.025.
Right. Okay.
So you don't use those leading zeros?
Leading zeros are just not significant. Okay. So 0.0251, and since this is moles of solute over liters of solution, that is molar concentration. I can just put an M with a line under it. Chromium bromide solution. Okay. And that's the answer we're looking for number 1.